Welcome to Conscious Evolution, an antidote to meaninglessness. A podcast by Robert Cobbold. Creativity is one of the enduring mysteries of the universe. How does something more keep coming from something less? Just over 100 years ago, one original answer to this question came from the French Jewish philosopher Henri Bergson. In his book Creative Evolution, Bergson argued that rather than being driven merely by deterministic laws of cause and effect, evolution was at least in part propelled by a vital impulse, which he called élan vital. Bergson believed that élan vital could account for human creativity, and that the real consequence of evolution is a mental freedom to grow, to change, to seek and create novelty. He wrote, "There is no greater joy than that of feeling oneself a creator. The triumph of life is expressed by creation." In this series, we've been taking an earnest look at what many people consider to be the most important question of all: how to be happy. But when we listened to what the experts had to say about it, such as Roy Baumeister speaking here on the Psychology podcast, we realised that the overwhelming weight of evidence pointed to the conclusion that
you pursue happiness for its own sake. And the pursuit of happiness, of course, is one of the founding American ideals. Pursuing happiness for your own sake doesn't really work. But if you try to cultivate a meaningful life, that can work, and that will make you then happy too. So fits what I said, meaning is more of a prerequisite for happiness, and not so much the other way around.
So our inquiry into how to be happy has really become an inquiry into how to find meaning in life. Trouble is, although the engine of capitalism is incredibly efficient at furnishing us with new and better ways of seeking pleasure, it's chronically bad at helping people find meaning. In fact, it tends to do the exact opposite. It finds sources of meaning and then systematically commodifies and commercializes them until they become empty and hollow. To make matters worse, our value systems, the stories that we've been telling ourselves about what is right and what is wrong and what is worth aiming for in life, the stories whose role it is to point to our place and purpose in the universe and to provide our lives with meaning, is breaking down in the face of a series of converging crises. The social crisis, the climate crisis, the mental health crisis are all underpinned by a deeper and more fundamental crisis. This is a crisis of meaning.
The threat is nearly invisible in ordinary ways. It is a crisis that strikes at the very heart and soul and spirit. We can see this crisis in the growing doubt about the meaning of our own lives and in the loss of a unity of purpose.
In order to counter this crisis, I'm trying to construct a new story of meaning. And to help me do so, I consulted one of the most inspirational voices of the 20th century, Holocaust survivor Viktor Frankl, who somehow came through the experience of Auschwitz still convinced that life was meaningful.
This uniqueness and singleness, which distinguishes each individual and gives a meaning to his existence, has a bearing on creative work as much as it does on human love.
In his book Man's Search for Meaning, Frankl claims that love and creativity are the most powerful sources of meaning in life, and many modern psychologists agree. In episode 1, we explored 3 pillars of a meaningful life: cooperation, creativity, and a third which Frankl also touches upon in Man's Search for Meaning: transcendence. In episode 2, we explored cooperation through the lens of evolution. We heard that from the first single-celled organism right the way through to modern nation-states, the scale of cooperation has been steadily increasing as evolution has progressed. Cooperation, we discovered, is a trajectory of evolution. We also realised that unless this trajectory continues, unless we find a way to move beyond nations and form some form of global cooperative, then humanity's evolution will dead end. Finally, we put the two together and landed tentatively on a theory. Humans find cooperation meaningful because it is essential if we're to have an evolutionary future. Can we say the same about creativity? Does the universe get more creative as it evolves? And can this shed any light on why humans find creativity meaningful? Before diving into these difficult questions, it would be good to try and get a handle on what creativity actually is. Here's one of the world's leading experts on creativity in education, Sir Ken Robinson.
Creativity, as we define it, is the process of having original ideas that have value. The process of having original ideas that have value. These three things are important. It's a process, it's not an event. Much more often, creative work evolves in the making of it. It's a conversation between the material and the idea, and often the idea that we end up with, or the piece of work we end up with during the course of a creative process, is not the one that we had in mind when we started out. It's an evolutionary process.
When Sir Ken defines creativity as an evolutionary process, he isn't talking about biological evolution, he's talking about human cultural evolution. He's talking about the variation, selection, and reproduction of original ideas or memes that have value, as opposed to original genes that have value. We tend to think of culture and biology as two entirely separate things. We talk about man-made things and natural things as if there's no overlap. But what the nascent field of cultural evolution tells us is that the mechanism whereby ideas come to spread throughout the human population is exactly the same as the mechanism whereby genes spread throughout a population. Take a new recipe, for example. Let's say I write a new recipe for a cheesecake and post it online. If the recipe's good, people will recommend it to their friends and it will end up spreading. Then let's say someone comes up with an innovation. Add a couple more yolks here, remove some cream cheese there, and bingo, they've improved the recipe. Then the two variants of the recipe will compete with each other, and whichever recipe is tastier will end up spreading more widely. That is variation and selection at work, pure and simple. The only difference is that the information about how to make the cheesecake is transmitted from organism to organism via language, as opposed to biological evolution where adaptive information is carried in our DNA. But cultural evolution is about far more than just cheesecakes. Languages, businesses, technologies, religions, fashion, music, even something as abstract as systems of governance, all undergo variation and selection, all undergo cultural evolution. And just like our genes, they jostle and compete to drive our behaviour. Here's Jason Silver talking about the power of cultural evolution.
Turns out that ideas are just as real as the neurons they inhabit, as James Gleick tells us. A new kingdom rises above the biosphere. The denizens of this kingdom are ideas, because ideas have retained some of the properties of organisms, it turns out. They leap from brain to brain. They compete for the limited resources of our attention. They have infectivity. They have spreading power. They are what Richard Dawkins calls the new replicators, born from the primordial soup of human culture. Their vector of transmission is language and electronic communications. And though ideas are not made of nucleic acid, they have achieved more evolutionary change, and at a rate that leaves the old gene panting far behind.
What Jason Silver is pointing to is that cultural evolution isn't just an analogy for biological evolution. Cultural evolution emerged out of biological evolution, is a continuation of it. Here's Carter Phipps, author of the fantastic book Evolutionaries.
Somewhere around 50,000 years ago, something happened where evolution seemed to break out of just merely the march of biology. And you have these moments in the evolutionary journey, even in the biological evolutionary journey, where it's like evolution breaks forward into a new space. A new capacity is created, and then evolution can move forward in a way it can't before. Something happens where evolution kind of takes a leap beyond biology, and human culture becomes a place in which evolution is taking place. So human culture over the last 50,000 years has changed enormously. But that piece of cultural evolution seems to sit atop biological evolution. And how much has our biology changed? Well, not near as much. And so cultural evolution becomes the avenue through which this incredible new journey of evolution is proceeding.
And even before biological evolution, some theorists have started to use the term cosmological evolution to describe the unfolding which took place in the universe before life first emerged. Often people find it difficult to think about cosmological, biological, and cultural evolution as one process, because for so long the term evolution has been synonymous with biological evolution alone. But whatever you want to call it, There is a process occurring in the universe whereby a cloud of hydrogen gas becomes rosebushes, giraffes, and humans, as cosmologist Brian Swim famously quipped. And if we're able to take a step back and expand our definition of evolution in this way, we'll see that there is a way of thinking about that entire process which is consistent throughout all these successive levels of evolution. And that way of thinking is in terms of emergence. Here's integral philosopher Steve McIntosh.
So this is a key idea in understanding evolution and where it's going. And that is that since the beginning of the Big Bang, right, the primordial emergence that occurred 13.8 billion years ago, there's been this series of additional emergences which have built upon the previous levels, right? So we can see, from hydrogen atoms emerges the heavier atoms. From atoms emerges molecules. And at the macro level, we're moving from first-generation stars to second-generation stars. So there's this series of emergences where something more keeps coming and building on what came before. And you see that in cosmological evolution, and then you also see it, of course, in biological evolution, right? Cells are built upon by more complex organisms. Then there's the emergence of major forms of organization like the neuron or the vertebrate or red blood, or all of these biological innovations that have built upon what's come before and which have extended this structure of emergence.
And of course, the structure of emergence is extended yet further with cultural evolution. Philosopher Daniel Schmachtenberger also defines evolution in terms of emergence. Here he is on Charles Eisenstein's podcast, A New and Ancient Story.
To define what evolution is, not just in a biologic sense, but the deepest sense that complexity science gives us is that evolution is an increase in ordered complexity that leads in the direction of emergent properties, and that what's being selected for are emergent properties. So, a cell respirates, even though none of the molecules on their own that make up a cell respirate. It's an emergent property. And so there is advantage to those molecules being together from even a thermodynamic perspective that there isn't being apart. So we can say that biologic evolution is a special case of this larger principle by which subatomic particles come into atoms, into molecules, that there is a process of increasing complexity. But specifically, complexity that doesn't have emergent property doesn't get selected for. So it's ordered complexity in a certain way.
I was interested to see what a complexity researcher would make of Daniel's definition of evolution as an increase in orderly complexity that leads in the direction of emergent properties. So I spoke to Kelly Smith of Clemson University, who uses his understanding of the trajectories of evolution in his work with NASA. Although he uses slightly different terms, you'll hear that his definition of evolution isn't too far away from Daniel's.
I probably agree with him, and if we had a beer and sat down and talked about it for 30 minutes, we might have some really interesting things to exchange. It's intuitively appealing to say something like the complexity of the universe is increasing over time, and that needs an explanation and maybe suggests a deeper trend in the universe. I think in a way that's right, but I don't think it's actually complexity that we're concerned with. What's happening, rather, is that the constituents of the universe are coming together in new ways. And so I think it's really more about the creation of novelty. The universe is creating more and more novelty over time. And the novel constituents it creates are better and better at creating additional novelty. So the rate at which novelty is being created is increasing. I do think that emergence is a promising way of thinking about this. When you think about emergence or the creation of new systems, my intuition is that what we're really interested in is the creation of new types of systems which are more capable than previous systems of generating even further new types of systems, so that the rate at which novelty is created increases over time.
One example of what Kelly's talking about is the transition from biological to cultural evolution. Biological evolution created the vast diversity and complexity of ecosystems which we see around us. And out of these ecosystems emerged humans, who are capable of creating even more diverse and complex systems in the form of human societies and culture. Language is a symbol system which is capable of creating novelty in the form of textbooks or scientific journals, for example. And the information stored in those novel forms helps us to go on innovating and creating yet more novelty whether it's new technologies or new scientific theories, and so on. And so as innovation breeds innovation, the evolutionary process accelerates. The acceleration that comes with the invention of language and the transition from biological to cultural evolution is not an isolated incident within the history of life on Earth, but rather the latest example of an entire sequence of evolutionary transitions in which the process of evolution has itself evolved, accelerated. Here's evolutionary theorist John Stewart.
There are two great streams in the trajectory of evolution on this planet. One is the emergence of cooperative organisations of wider and wider scale as evolution proceeds. And the other is the evolution of evolvability.
In case you missed it, the trajectory of wider and wider scales of cooperation was the subject of the last episode.
If we move to the second great trend in evolution on this planet, the increase in evolvability, we can start off with the genetic process where adaptations were discovered by blind mutation of genes. That process is totally random in the sense that the genes of an organism can undergo mutations and a very tiny proportion of them will ever be successful. So it's a very wasteful process, but it did enable evolution to occur.
John's talking here about asexual reproduction, where organisms reproduce just by copying themselves and their genetic material. This means that, other than occasional mistakes in the copying process, or mutations, each generation is identical to the last. And this means that evolution is very slow. Dear listeners, conscious evolution is a philosophy which argues that global cooperation is the necessary next stage in the evolution of life on this planet. But the tricky question is, how do we get from here to there? And how can it be done without the need for a world government? It's all very well saying nations need to cooperate, but how will citizens have their say? And how do we make sure that governments act when it's not in their short-term interest to do so? The only workable solution that I've ever come across is Simpol. Simpol provides a pathway out of destructive competition between nations and towards fruitful global cooperation. A growing number of politicians around the world support it, but in order for it to work, we all need to support it. Humanity needs global cooperation in order to survive this century. By signing up to Simpol, you actually take a practical step to help us get there. You can do so right now at simpol.org. And now, back to the podcast.
The next major evolutionary transition in the evolution of evolvability was the emergence of sexual reproduction. The significance of sexual reproduction is that it doesn't rely on the blind mutations. What it does is recombine genetic elements from generally two different organisms to produce the offspring. Now, the reason why that's significant, why recombination, combining different elements, genetic elements, is superior in terms of evolvability to mutation, is that it tends to produce variation that has a much higher chance of being viable in its own right. So if you have two organisms that have lived and survived, and if their genes are mixed together through sexual reproduction and recombination, there's a higher probability that the result will be something that's functional and a higher probability that it will be successful in the environment that it's born into. So sexual reproduction was a major step forward, a major evolutionary transition.
One way of understanding these evolutionary transitions is that evolution itself gets better at evolving. Notice also how there's a layering effect. Just as the emergence of cultural evolution didn't mean that biological evolution stopped, the emergence of sexual reproduction didn't bring an end to asexual reproduction. Many single-celled organisms still replicate by asexual reproduction, but the increased efficiency and effectiveness of sexual reproduction means that while many single-celled organisms are not drastically different than they were 500 million years ago, sexual reproduction has produced a magnificent kaleidoscope of ever-proliferating life forms, until eventually it produced creatures who were complex and conscious enough to learn new behaviours during their lifetimes.
We followed with major evolutionary transitions such as learning, the capacity to learn during an organism's life. Genetic processes can't evolve during an organism's life learning processes that are generally brain-based and nervous system-based can do that.
A dog, for example, is intelligent enough to learn a new trick. Or an elephant can learn the route to a new watering hole. Or, as shown in a recent David Attenborough documentary, polar bears have adapted to climate change by learning to hunt beluga whales by leaping onto them from rocks. These are all tricks that have been learnt during the animal's life. They aren't programmed to behave in these ways by their genes. And this ability to learn allows them to adapt during the course of their lives, rather than biological evolution which takes place over generations. But there's a downside to this. Because what's learnt during the animal's lifetime isn't encoded in its genes, when it dies, that learning dies with it.
That brings us to cultural evolution, where up until then, learning could occur, but it would be lost when an organism dies. What it's learnt isn't passed on. It's only with humanity that major evolutionary transition to cultural evolution took place. And what was learnt during an organism's life could be passed on and accumulated as a culture. The emergence of cultural evolution, the accumulation and passing on of cultural knowledge in all its facets, including science, psychology, economics and so on, gives rise to an explosive increase in the rate of evolution, the rate of innovation, the rate of discovering and building effective adaptation. So through the process of cultural evolution, for example, in a few thousand years, humans developed the capacity to fly through the invention of aeroplanes and so on, while it took gene-based evolution, the biological evolutionary process, millions upon millions of years to discover by blind trial and error.
In the first episode, we heard positive psychology professor Scott Barry Kaufman equate creativity with the ability to be adaptable. And what John Stewart is saying here is that in an evolutionary sense, this is literally true. Humans are more adaptable than other species because we have creativity. We're able to make tools, stitch clothes, develop medicine, and all the rest of it. In other words, we're more adaptable because we have cultural evolution. And all this cultural evolution is powered by human creativity. But human cultural evolution is just the latest extension of the evolutionary trajectory towards ever more evolvable life forms. As evolutionary psychologist Stephen C. Hayes wrote in a recent article, survival of the most adaptable is far truer to the whole of evolutionary data than the hoary phrase survival of the fittest. We've covered a huge amount of ground here, so I'm going to pause for a moment and summarize. For 1 billion years after the Big Bang, the universe was nothing more than a cloud of hydrogen gas, the most basic building block in the universe. Gradually, these clouds of hydrogen gas collapsed to form stars. And from the explosions of these stars formed the heavier, more complex elements, which were eventually pulled together by gravity to form planets. After about 9 billion years of this painstakingly slow process of cosmological evolution, of stars forming and exploding and forming again, and planets slowly pulling themselves together in orbit around these stars, the Earth was formed. And at some point, and we're still not exactly sure how, life emerged on this Earth, kickstarting the process of biological evolution. But the first life on Earth could only reproduce asexually. That is, by simply copying the genetic material of each generation to produce the next. This means that each generation is almost identical to the last. And so for another 3 billion years, evolution plods along incredibly slowly, with very little increase in complexity. Eventually, life found a way to reproduce sexually. That is, by mixing the genetic material of two different organisms together. Because each offspring from sexual reproduction is unique, there is far greater diversity for evolution to go to work on. Evolution acquires a new creative capacity, which is more efficient at discovering successful adaptations. And so the foot goes down on the accelerator. And in only 1 billion years or so, we go from incredibly simple single-celled organisms to more complex life forms such as plants, insects, fish, dinosaurs, and so on. Eventually, organisms evolve that are complex enough to have brains and nervous systems, so they're able to learn behaviors during their lifetimes. But it's not until the evolution of modern humans some 50,000 years ago that we develop the ability to store and transmit these learned behaviors through language. ushering in the dawn of cultural evolution. And so cultural evolution becomes evolution's newest creative capacity, the new space into which the process can accelerate. And so while stars and planets are still forming over eons of cosmological evolution out there in space, and biological evolution is still trundling along over millennia under the sea and in the forests, the human race is being catapulted forwards with every passing decade of cultural evolution, as our tools and technologies and societies get more and more complex. What begins as a drop turns into a trickle and ends as a torrent. And so to return to our original question, yes, the universe does indeed get more creative as it evolves. And human creativity is just the latest expression of that trajectory. Adaptability, evolvability, creativity. All different ways that we can use to characterize this evolutionary direction. And there's another way to think about it as well. Freedom. Here's me talking to integral philosopher Steve McIntosh. And I heard you mention that our freedom increases as evolution progresses. Do you see that as a pattern?
Sure, I think we could even say that freedom is a direction of evolution. That certainly things that are just subject to the laws of physics, right? Atoms and molecules, forms of universe organization prior to life are clearly determined. The degree of freedom that is available to an atom is highly limited. But with the emergence of life comes the emergence of a significant degree of freedom. Stuart Kauffman, for example, the famous systems scientist, has written about the quasi-purposive behavior of amoebas, right? He talks about bacteria as minimal molecular agents because they exhibit agency that no computer could possibly predict. There's a degree of freedom that even the most primitive life forms exhibit that breaks out of the deterministic influences of the laws of physics alone, right? And then as life evolves and complexifies, its degrees of freedom continue to increase, as animal consciousness evolves.
Biologist Lynn Margulis defines life as matter that chooses. And that choice, however primitive, implies a certain amount of freedom from determinism. But that leads us slap bang into the middle of one of the most famous philosophical arguments of all time, the debate between free will and determinism. If everything in the universe is made of matter, and matter can be shown to follow deterministic physical laws, then free will, it is argued, must be an illusion. This may fly in the face of everyday experience, but there are no shortage of brilliant people throughout history who've come to exactly this conclusion. But if correct, this has devastating consequences for morality. Because if no one has free will, then no one can really be held accountable for their actions. What Steve McIntosh is articulating here is a potential resolution to this problem. Free will may not exist in the physical world, in the world that existed prior to life, but perhaps free will is an emergent property, which gradually increases as evolution produces life forms that are more and more complex and more conscious. And this emergence continues with humans.
There's a degree of freedom that emerges with the advent of humanity, which continues to evolve. Now, one of the authorities regarding this proposition that as humans develop, as their consciousness becomes more complex and their culture allows them to have a greater degree of knowledge and experience, that free will itself evolves. So Abraham Maslow is a fairly well-recognized mainstream authority, right? The developmental psychologist famous for the hierarchy of needs theory.
For those of you who aren't familiar, Maslow's hierarchy of needs is the idea that human needs can be set out in a pyramid, from the most fundamental to the most lofty. At the bottom of the pyramid are physiological needs like air, food, and water. Then come the need for shelter, safety, and security. Then the need to belong, the need for family and friendship. And once those needs are met, you move on to the need to be valued and esteemed by your peers, and so on. All of which sounds straightforward enough. But what people often miss out is the need which Maslow reserved for the apex of the pyramid, which he called the need to self-actualize, to fulfill one's creative potential, and to find meaning and purpose. It is this need to which this podcast speaks. Maslow's great insight is that as you satisfy each need and move up the hierarchy, you actually become more free. For example, if you're starving or sick or in physical danger, then your degree of freedom is very limited. your range of effective choices narrows to those which will enable you to survive. But as the progress of human history has resulted in better material living conditions around the world, and we've gradually reduced starvation and disease and warfare, more and more people have been freed from the struggle for survival. More and more people are moving up Maslow's hierarchy and are now able to pursue their need to create, find meaning, and self-actualize.
According to Maslow, as people move up the levels in his hierarchy of needs, the more self-actualized people become, the less determined they are, the less pushed around by cultural forces they are, the more they're able to think for themselves. And that's an example of how not only does freedom increase with the scale of biological evolution, but freedom continues to increase in this realm of what we sometimes call noosphere evolution, right? After Teilhard de Chardin, another famous evolutionary philosopher, talks about the physiosphere, the biosphere, and then this realm of human evolution, which he calls the noosphere. And as evolution in the noosphere, as the evolution of human consciousness and culture occurs, this direction of freedom is clearly a direction. Now, that's not the only direction.
Another direction is, of course, cooperation. At the end of the last episode, we came to the tentative conclusion that meaningfulness was evolution's way of telling us that we're doing something which is conducive to our evolutionary future. Humans find cooperation meaningful because unless humanity can find a way to push the scale of cooperation to the global level, then humanity is highly likely to go extinct in the next century. Is the same true of creativity? Absolutely. Many of humanity's greatest problems, whether it's the fight for social justice, the climate crisis, or even the coronavirus crisis, can only be solved if we keep pushing that trend towards increased creativity forward. We're going to need every ounce of human ingenuity if we're going to emerge out of this difficult period and survive this century. But if hundreds of millions of people are still stuck at the bottom of Maslow's hierarchy, we're missing out on their creative potential. How many Shakespeares have we missed out on because they were never taught how to write? How many Mozarts who couldn't afford a musical instrument? How many Martin Luther Kings who didn't get access to a university degree? That's why, from an enlightened point of view, the material welfare of every human on the planet is in your direct interest. As Daniel Schmachtenberger explains on the Future Thinkers podcast,
you are a unique emergent property of reality, and you have had life experiences. You've sensed stuff that I haven't. You have a perspective on everything that I couldn't possibly have. You have the ability to do stuff that I can't do. If you self-actualize fully, you will create beauty in the world that I couldn't. No amount of Michelangelo's self-actualization would have done M.C. Escher or Salvador Dali. Like, they're their own fucking kinds of unique creation capacity. So now the competition thing is gone. You self-actualizing not only doesn't take away from me, you self-actualizing makes a more beautiful universe in a way that I can't, but I want to live in that more beautiful universe, so I'm incented to help you self-actualize.
And so cooperation, creativity, and freedom are inextricably bound together in the spiral of evolution, as each reinforces the others. As philosopher Forrest Landry wrote, the degree of individual freedom in a society increases dramatically in proportion to the degree of cooperation among individuals. Or, to put it succinctly, love is that which enables choice. Conscious Evolution is a podcast by Robert Cobbold, with editing by Thomas Glasser and sound design by Mark Pitton. Viktor Frankl was played by actual Holocaust survivor Werner Reich. You can hear more about his story by looking up his TED Talk, How the Magic of Kindness Helped Me Survive the Holocaust. I'd also like to give a special thank you to Carter Phipps, Steve McIntosh, Kelly Smith, and John Stewart for speaking to me, and for Daniel Schmachtenberger for giving me permission to use his audio from other interviews. I'd also like to thank Robbie McInnes for all his support and guidance in the art of podcasts. But in particular, I'd like to say thank you to Afro-Celt Sound System for letting me use their extraordinary music in the soundtrack. All the songs you'll hear in this episode are by Afro-Celt Sound System, including this one. You can listen to their latest album, Flight, on Spotify. This podcast is entirely a labour of love to help people find meaning in life. Spreading the word about conscious evolution certainly gives my life meaning and purpose, but all the same, every interview, every hour of editing, and every cent on advertising has to be paid for out of my own pocket. So if you drew something valuable from listening to this episode, then please consider supporting me on Patreon, even if it's for the smallest amount. You can find a link to my Patreon along with the other episodes, interviews and articles on consciousevolution.co.uk.